Okay, we have a MacBook Pro. It's the 2020 design. 2020 13 inches. No power. It says liquid damage powers on, shuts shuts down. Powers and then shuts down. Okay, so let's check out what we have. First and first, remember, like I always said, guys, when you're working on a liquid damage device, you want to first have a better idea of what you're doing before you connect your charger. So what you want to do now, first and first, is to take out our back cover before we uh, before we connect our charger. So the description says the device does power on and then shuts down. So before we before we attempt to connect our charger, first we want to be sure that we have a better idea of exactly what is wrong with the device. Okay, you can see some form of corrosion in this section. Yeah. Okay. Now, before we connect our charger, right now it's not safe to connect our charger until we take out the board, and then we can get to see both sides of the board. So right now we don't know if there is um, any more damage as a result of the liquid on the other side of the board. So we do not want to just connect our charger, because by doing so you may uh, cause more damage to the board. So we want to take out the board completely before we can connect our charger. So this should be the approach generally with liquid damage devices. Before you connect your charger to it, for sure that it is safe to do so. Otherwise, you might just be creating more harm on the device. Because sometimes you might not see the whole picture, which is you might not see everything that is wrong from one side of the board, which is why you need to take the board out to have a better look or a better view of the entire board. Okay, screws are out. Now we want to disconnect our cables. So I usually like to follow a pattern, which is I either take out the screws first and then the cables second, or I take out the cables first and then the screws. So that way you kind of it's actually better if you follow a system, whichever works for you. Either you take out the screws first. Hmm. Either you take out the screws first and then the cables after, or whichever. You can as well take out the cables before the screws. But I'm thinking doing both simultaneously my kind of um, you may forget to unplug a particular cable or yeah, it's really no downside to whatever option you choose. If you also want to do both simultaneously, which is taking out the screws as well as disconnecting the cables at the same time, still all good. No issue with that. Okay, the board is out. Now we want to put the shell aside and then have a better look at the board. Okay. On the other side of the board, it's not so bad. Uh, we also have a bit of corrosion in this section of here. That's the section of the Wi-Fi Bluetooth antenna cable. That's where the antenna cable is connected to the logic board. And then on the other side, we have a bit of corrosion as well on the Wi-Fi Bluetooth part. So what you want to do first, still we don't want to connect charger to it. We want to check for short. So before that, let's open up the board view. Board number is 820-01987. So 820-01987. 820-01987. Um, okay, it's doesn't seem to be in our recent. So it's 820-01987. Okay, here we go. That is the board. So we have a bit of a corrosion here at U3701. Now what we want to do is and also when we flip to the other side, we also have a bit of corrosion here by the antenna. So we have a bit of corrosion here as well. So we want to, before we connect our charger, we want to see if we have a short. So we also try to dust the board. Okay. Um, this caps here. This caps here. They obviously have to go. But then let's say if we have an issue, if this caps has created an issue on that line. So what we want to do is let's see what those caps are for. Uh, so that it's the PP3V3 underscore G3 G3S underscore wireless and Bluetooth. So let's see if we have a short on that rail. Let's switch our multimeter into continuity mode. Okay, black probe to ground, and then our red probe. Let's see if we have a short. Okay, so we do have a short on this rail, which is PP3V3 underscore G3S. So definitely from what we are seeing, so because as we can see, this cap here seem really bad, that seem really bad, the two caps seem really bad, and as you know, the cap itself. So one side it's connected to the main line, to the PP3V3 G3 S line, and then the other side of the cap is connected to ground. Now, in between, there's an insulation in between. So basically, the way it's designed, it's such that there will be a separation between your pin 1 and your pin 2. However, when the cap is damaged, so ordinarily, this cap, one side will connect to the line and then the other side will connect to ground, which is G and D. Now, when this cap fails, what happens is this side, the material in between, will no longer be able to hold to create separation between between both pins. So what will happen is when particularly when cap fails is whatever is on pin 1 will now go straight to ground, and then obviously what that means is every line that this line is connected, every component or circuitry that's represented, and this line will be shorted or will be connected to ground because of a failed cap. So it's almost like it's almost going to work like a wire now because there's no longer any form of insulation between. So what you want to do is we are going to hope that the caps that we have here are the issue and not our Wi-Fi card. So if you look at the Wi-Fi card, I seem to look a little funny. I hope that's not a hole on it. Let's clean that and see if it's not a hole. Okay, so what you want to do is we want to remove those caps first, the ones that seems really bad. Okay, we want to measure again to see if we. So we have taken out the caps, the ones that seems really bad. So let's measure again to see if we have a short. We still have a short. Okay, so let's see where more of the caps. Okay, we're trying to take more out, trying to take more of the caps out that are affected. Let's see, do we have a short still? Yes, we still do have a short. Okay, so this is out of the line. This it's out of the line. These two are out. Um, so the next thing we want to do is let's go back around the Bluetooth, the Bluetooth chip itself, and there is this also C3725 seems a little funny. Okay, which is this there. I'm just gonna show you guys. So that looks funny also. So we want to take that out. This is 3725. We want to take that out and see uh, if our issue, the short, will be resolved. Okay, that cap is out as well. See if we have a short still. So I'm just hoping that um, the card itself, because I can see some kind of a hole on top of the card. Let's just hope the card itself is not the cause of the short. Let's check again. Okay, so the short is gone. Now we no longer have a short on that line. Okay, so that's good. We no longer have a short on that line. Um, Now let's try to clean out that section. You see, all of the times we are still yet to connect our charger because you want to connect your charger when you're sure that it is safe to do so. So although this particular rail that is shorted, even if we were to connect our charger, there will be no harm, so to say, um, to come from the charger. So uh, so trying to now let's connect our charger. See what we have. Switch on multimeter to voltage mode. Then connect our charger. Uh, USB-C USB-C charger. Okay. Okay. Let's see what we have on our PP bus. Let's switch that. This high. The board is oriented this way. Okay. So yeah, like this. So let's see what we have on our PP bus. PP bus is going to be on this fuse here, which is this. Let's see what we measure on our PP bus. Because what we measure on our PP bus will give us an idea what we have on our PPDC in. 12.62. 12.62 tells me that my PPDC in is 20 volt, I am getting the right voltage at my PVDC in. And then also 12.62 tells me that the device is actually starting. Yeah, that tells me that the device is starting. So let's just measure any of the SO rail. Okay, so we're measuring at an inductor which is L7690. Okay, that's not an SO rail. Um, okay, let's check L70. Okay, yeah, let's see what we have on our L7670. 5.1. So, okay, yeah. So basically, this logic board is starting. So what we want to do now is we want to put the board in the shell and see if we actually have a board that is starting, and hopefully it's posting. And most importantly, we want to check to see that the Wi-Fi section of the device has not been affected. So we will put into recovery to say if the device powers on. So first let's see if the device actually powers on and then boots. Then yeah, take it off from there. So the description of the device says the device powers on and off. So I suppose that description, it's a one-time description, which is the device went on and then went back off. So it's not like the device goes on and off, because when you have a short on your 3-volt line, that particular rail, um, you you will not have a device that will boot, obviously, that will start up, boot your desktop and then go off. No, you will not have that behavior. So it could be like a one-time thing that yes, before the cap actually failed completely. So the device did boot up and then went off, and that's it. Didn't come back on again. So so the thing is, usually when you have issue with when this liquid spilled to your device, try to go to, even if the device is working, try to go to your nearest repair shop. Let them have a look at your logic board for you, so that there is no section of the board that has started to corrode. Because when that happens, it's a gradual process. Depending on how much damage, um, depending on how much damage there is, that determines how fast the device will fail. So you want to kind of prevent it before it eventually happens. So even if the device, if you experience any type of liquid spill on your device, just okay, as a precaution, obviously make sure that you do not have power introduced to the device, and and see if you can walk into any of the repair shop for them to have a look at the device for you. Specifically, you want them to verify that your board is safe and there is no section on the board that has started to corrode, because corrosion is obviously what will damage the components, and then the solder pads will also be gone. And the more the device is being used in that state, the more damage that you can potentially cause to that device. So, just before, even though the device works fine, I really, really recommend that you take the device into any repair shop around you. Let them have a look at the device for you, and especially the logic board. It's not just having to just guess work to say, oh yeah, okay, if it's working, then it's working. No, yes, it may work, but you want to be sure that none of the section of your logic board has started to corrode. Because if you tackle it while it's still before the process actually begins, you stand a better chance in getting the device up and running, and also having a device you use for a long time. Okay, so the board is in. Let's see if the board is starting. Connect our charger. Do we have haptic feedback? Okay, we do have haptic feedback. That's a good sign. Let's see if we have an Apple logo. Do we have a chime? Do you have an Apple? Okay, we do have an Apple logo. That is also good. Now, what you want to do is you want to shut the device down and then put into recovery to see if we have. Okay, fine. We do have a test account. Let's use the test account. Test account. Okay, 1, 2, 3, 4. Uh, okay, 1, 2, 3, 4, 5. 1, 2, 3, 4. Test account. Okay, 1, 2, 3, 4 seems to work on the test account. Now it's loading. I don't know. I'm not sure if you guys can see that. Uh, like this. Okay. Okay. So now it's loading into the test account. So this is good. I mean, the device is start okay. Touch bar. It's up also. The backlight is now brighter than it were. And good thing, some of the keys are actually fine. So though one of the keys missing, but that's not a problem. That can always the keycap can be replaced. Okay. So this is the test account. The device is up. Now we want to see if we have Bluetooth functionality. Okay, this is good. This is good. So this tells us that the card is still working because if the card was not working, we may not have this may not be picked up. The Wi-Fi the Wi-Fi's may not be picked up. So okay, yeah. So Wi-Fi. So let's connect to one of the Wi-Fi around. See if it connects also. So it's a 585289997. Okay, let's see if it connects. Okay, yes, that it is actually connected. I'm sure if you guys can see that. It's that see that it's connected. Okay, now let's see if let's just go to okay. Okay, so this device it's yeah, this device is done. So what we want to do is by the way, the network here is quite slow. So yeah, this is not necessarily related to um, the authentication or yeah of the repair itself. So the Wi-Fi is slow, so this is expected. So my worry concern was basically that I we are able to pick this up. Melissa Tech. Oh, okay. Is this around here? Say again. Oh, Jibril. Oh, okay. Okay, yeah. This is done. So what we want to do now is the device is heating up quite a lot. So during the finalization process, we will also have to apply thermal compound to the CPU, and then the device can be finalized, and the client can be called to collect the device. So I saw I saw your reflection. Yeah, no. I saw Melissa Tech among the available Wi-Fi, and I'm like, oh, Melissa Tech is around here. Okay, it popped up on your yeah, okay, yeah. It's all like Melissa. Okay, then I asked them, is Melissa Tech? Okay, before we see you, we see your Wi-Fi. Okay, guys, that's gonna be the end of the video. See you guys in the next one. Thank you.